So this problem is going to be a multi-step problem because what I'm given in the problem, my given is wavelength. This is my lambda. And I'm being asked about energy. And so there are two different formulas that I'm going to need to use for this. The first one is the speed of light equals wavelength lambda times my frequency. That's one formula I'm going to have to use. And then the other one is energy equals Planck's constant, h, times my frequency. And so what you can see, and I'm hoping you're able to tell, is the fact that since I'm given wavelength here, I'm going to first need to plug it into this formula right here to find my frequency. And then I can take frequency and solve for energy. So I'm going to start off. What you should notice is that my wavelength is in centimeters. But I can't use centimeters because the units for my speed of light are meters per second. So I'm going to convert this very quickly to meters. So I'm going to put the units meters up top and centimeters on bottom. In 1 meter, there are 100 centimeters. So this is going to be 0.12 meters for my wavelength. So I'm now going to plug it in. So I've got 3.0 times 10 to the 8th meters per second for my C right here. That equals 0.12 meters times my frequency. Okay, and so what I'm going to do is I'm going to divide both sides by my wavelength, which is 0.12 meters. And what I end up getting for my frequency is 2.5 times 10 to the 9th seconds to the negative 1. So that's my frequency. I'm not done yet because I'm trying to solve for energy in this problem. Now what I'm going to do is I'm going to use my energy formula. Energy equals Planck's constant, which is 6.626 times 10 to the negative 34th. My units are joules times seconds. And I'm going to multiply that by my frequency, which I got in the previous problem. So 2.5 times 10 to the 9th. And my units are seconds to the negative 1. And so what you should realize really quickly, seconds here are going to cancel with seconds to negative 1. So my units for energy are just going to be joules, which I would have predicted. And so what I end up getting for this, once I multiply 6.626 times 10 to the negative 34th by 2.5 times 10 to the 9th, I got 1.6565 times 10 to the negative 24th. My units are joules. Now I got to go back and figure out significant figures. Well, there are 2 sig figs here, there are 2 sig figs here, and then there are 4 sig figs here. So notice I'm looking at the values that I'm given, not necessarily the ones that I calculated, because I could have rounded to the incorrect number of sig figs, but what I'm given. So the ones that I am being given include this guy right here, include my speed of light, which is right there, and include Planck's constant. And so using the fewest number of sig figs, which is 2, my final answer should be 1.7 times 10 to the negative 24th joules.